Hey guys, we're going to do a video here on guess and check. And guess and check is just like a mathematical way of figuring out how to guess an answer. Really, it's just something that we all do in our heads is really what it is. But the idea is this, is if you're solving a problem in your head, here's you, and you're thinking all in here about like what you're doing, somehow you have to get those thoughts out of your head and down onto paper so that somebody else can read them, see them, and understand your like thought process. And that's what guess and check is getting ideas out of your head and organizing them in a way that any person could look at your work, like strangers that don't even know you, and they could follow your thought process and really know that you understand something. So guess and check is an organization method. So you want to be organized. And a lot of times we like to use a table to do this. So when I say organized, I'm really thinking about a table that somebody can understand. You want it to be clear. You want a stranger to be able to pick up your paper, look at it, and know how you thought about a problem. But remember, really what it is you are guessing an answer, checking to see if it's right. So it is a little process of guess and check, just like its name is. So we're going to try a guess and check problem for the video, just to try an example and show you kind of what it looks like. So here is our problem. We have a problem about a 7th grade class. So here it is. The 7th grade class took a survey about their preference in flavor of ice cream. The choices were chocolate, vanilla, or strawberry. The survey found that 20 more people preferred vanilla over strawberry, and twice as many people chose chocolate over vanilla. If 100 students took part in the survey, how many students chose each flavor? Okay, so I usually read this one time, get a little bit out of the story, and I always have to go back and read it again. I probably read a guess and check problem 3 or 4 times while I'm solving, to be honest. But I did notice this, that there are chocolate, vanilla, and strawberry. So to organize my thought process here, what I'm going to do is make a table with those 3 things. Chocolate, vanilla, and strawberry. So what I'm going to do is I'm going to draw a line under this, kind of organize it into this table, and then I'm probably going to have to go back and reread some of this problem to see what's going on. So here it is. The 7th grade class took a survey about their preference in flavor of ice cream. Their choices were chocolate, vanilla, and strawberry. The survey found that 20 more people prefer vanilla over strawberry. 20 more people prefer vanilla over strawberry. So that 20 more means to add 20. So I'm going to keep that in mind, that there are 20 more than strawberry for vanilla. So that's going to be helpful. What else does this say? And twice as many people chose chocolate over vanilla. Twice means to double, to times by 2. There are twice as many as vanilla for chocolate. Now, if 100 students took part in the survey, okay, so we need one more column here. We need a total. How many people altogether? Well, there's 100 people in this survey, so the total's got to equal 100. And the question is how many students chose each flavor? Okay, so here we go. We have a start to this problem. So we need to start with a guess. We need to just begin guessing. And because I'm noticing that vanilla was 20 more than strawberry and chocolate was 2 times more than vanilla, I think I'm going to start my guesses with strawberry first. Like, just throw out a guess, like maybe there are no, we'll have to go small. Let's go for something like 10. Maybe there are 10 people who prefer strawberry. Okay, well, for vanilla, that would mean 20 more than 10. So 20 plus 10 is 30. 30 people would be getting vanilla. And for chocolate, that would be times 2 to double that. So 2 times 30 is 60. So 60 people prefer chocolate. So I now see that 60, 30, and 10 are my numbers. So I'm going to add that up for total. 60 plus 30 plus 10. Well, 60 and 30 make 90. 90 plus 10 is, oh my gosh, wow, 100. We just found our answer. So in my very first guess, I got the answer, which is really, really good. Like, oh, perfect. I guessed 10. The numbers worked. Awesome. But I don't want to stop here. Just because I get lucky and get the first guess doesn't really prove that I understand or know something. I want other people to believe me that I know how to do this process. So they might look at my paper and think, wow, they either got really lucky, wonder if they copied it off a neighbor, but there's no evidence of my understanding. So this might sound a little weird, but I'm going to go put some fake guesses in here. I'm going to be like, well, what if I had guessed 5? Or what if I had guessed 20? To show whoever reads my paper that I have a fluid process of guessing, really so everybody understands what I'm doing. Now, if there had been 5 strawberry students, vanilla is 20 more than that, so 20 plus 5 is 25. And chocolate is twice vanilla, so twice vanilla, twice 25 would be 50. And if I add that up, 50 plus 25 plus 5, that's 75 plus 5, that equals 80, and we needed 100 students. So this is an example of a too small guess, which I'm going to write over here. And if I had guessed strawberry was 20 students, well, vanilla is 20 more, so 20 plus another 20 is 40. And chocolate is twice that, double that, so twice 40 is 80. So I would have had 80 plus 40 plus 20. 80 and 40, that's 120 plus 20. This is 140. It's way too big. So I'm going to write over here, too big. And at this point, now that I have like 1 right answer, 2 wrong answers, I feel like I have quite a bit of evidence that shows like somebody could read my paper and like know what I'm up to. So I'm going to circle. I'm going to make it clear that this one was my answer. And at the bottom, I'm going to write a statement so that everyone's very clear on what I came up with. So I'm going to say there were 10 students. There were 10 students who preferred strawberry. There were 10 students who preferred strawberry. 30 vanilla and 60 chocolate. 30 vanilla and 60 chocolate, period. And now I don't think anyone could argue that I don't have a clear answer. Like my thoughts are on paper, my sentence kind of clarifies it all, and I'm good to go. So really, like the takeaway here with the video is to remember that guess and check needs to be organized. It's okay to guess and check an answer in your head, but then get those thoughts down on paper into a table so someone can read it. If you get lucky and you get the right guess in the first one guess or the second guess, you need to show a couple other guesses to show your work. So the rule of thumb is you should have at least 2 wrong guesses in your table to prove that you know what you're doing. Now, if you had to do 10 guesses to get the right answer, or it's a really hard problem and you end up guessing 20 times, that's fine too. As long as your thoughts make sense, and by the time you get to that 20th one, you got the right answer. So it takes as many guesses as it takes. In this example, I got lucky. The very first guess was right. So I had to make up some other guesses and show my math. And that is a guess and check table. Hope that helps.